This question you can see it came in May-June 2018, variant 3, A-level physics. It's a question number 7. It says two masses, capital M and small m. This is capital M here, this is small m here, are connected by an inextensible string. This is an inextensible string which passes over a frictionless pulley. Mass M, capital M here, rests on a frictionless slope as shown in the figure. The slope is at an angle theta to the horizontal. This is the theta angle. The two masses are initially held stationary. The two masses, capital M here, it is at rest, small m it is also at rest, and then released. Mass M moves down the slope. So what does it mean? That this force is greater than the weight of this one. So that's why it's moving down. Which expression must be correct? You can have a look what we have done. What we have done here, which is a capital mass M, we have resolved the weight of this mass, which is mg, into its two components. Here you can see AD is one component and DB is another component. You can see this angle is theta. If this angle is theta, so it is sure that this angle is also theta. If these both are theta angles, then mg can be resolved. AB will represent the horizontal component, it will be mg cosine theta. I am writing it here. Mg, this is the weight. Mg cosine theta, because this component AB, which is along the angle, it is mg cosine theta. It will be cancelled with the normal force or the contact force. Mg sine theta, which is opposite to this angle here, this will be responsible to bring it down. It means this mg sine theta, it is this component. Because of this mass will move down the slope. Because the capital M, this mass, it's moving down the slope when we have released it, so it means mg sine theta should be greater than this mg. That is why this mg sine theta is pulling it up and it's going down. So mg sine theta should be greater than mg. Small g will be cancelled on both sides, and we're getting capital M sine theta greater than small m, or sine theta is greater than small m divided by capital M. You may think here that how we have taken this angle theta is equal to this angle theta. Look, this is a situation I can tell you here in the separate diagram. If let's suppose we take the different colors, so just to make sure that you understand this. If this is inclined plane and this is the mass over here. Now this inclined plane, for example, I say it is making an angle theta here. Now the weight of this one, mg, it is acting vertically down like this. This is mg here, this is capital M. So mg is the weight of this one, because weight is mg, you know very well. Okay. When I'm resolving this one into two components, I say this is one component of this and this is another component of this one. It's making 90-degree angle here. If let's suppose I say I have two triangles right now. This triangle, I say this is point A here, and I say this point is B here, and this point is C here. So I can say that ABC is one right angle triangle. Exactly like this, if I say this is a point A and I'm considering this one a point B, and this point I'm taking as a point B, for example. So I say ABB is another right angle triangle. So I'm getting two right angle triangles here. I can show you here one right angle triangle. I'm drawing the symbol of that one is ABC. So I'm writing it here. The other right angle triangle is ADB. I'm writing it here for you, ADB. So you can see we have two right angle triangles. In these two right angle triangles, what we are getting common? See here, this angle is 90 in the right angle triangle ABC. This angle is 90. This angle is also 90 in the other right angle triangle, which is ADB. So two right angle triangles, they are getting the one angle equal. Exactly like this, if you can see here, this angle I'm showing you with the red color. This angle and this angle, they're equal, right? This is the alternate angle. So you can see over here, this angle, they're equal. So it means in these two triangles, two angles are equal. If two angles are equal, so it is sure that the third angle will also be equal. If this is theta, so it should be theta as well. That's why here, if you see what we have done, we have considered it. If this angle is theta, we say this angle is theta as well. So on the basis of this, we have calculated the horizontal and the vertical components. So opposite to the angle, we are always taking sine, and along with the angle, if you are considering this angle, we are taking the cosine function. So this is mg cosine theta, which I wrote it here, and this is mg sine theta, which is responsible to bring it down. That's why we got the answer C here, which is according to our calculation, sine theta is greater than m divided by